gonna prove your favorite derivative theorem. If f of x is equal to x to the n, then the derivative is nx to the n minus 1. And we're going to try to do the proof by definition. F prime of x by definition is the limit as h goes to 0 of f of x plus h minus f of x over h. The limit as h goes to 0. Now what does f do to what's in the brackets? It raises it to the nth power. So they put this in the brackets, whatever. I'm going to raise it to the nth power minus f of x. Now either you can read it off or you can say whatever they put in the brackets, you're going to raise to the nth power. This gets divided by h. Now this is the limit as h goes to 0 of, let's write down what that is. This is going to be n choose 0. It's going to be, or it is, n choose 0, which is 1, x to the n, plus n choose 1, x to the n minus 1, times h, plus n choose 2, x to the n minus 2, so now h squared, all the way down to n choose n minus 1, and we are going to have x h to the n minus 1 plus n choose n, which is 1, h to the n, minus this x to the n. And all of this gets divided by h. Now, n choose 0 is 1, and 1 times x to the n is x to the n. So this minus that is history. Now, if you look at each and every term, they all have an h in it. They all have an h in it. And the whole thing with these derivative limits is to divide by h. So I'm going to factor out an h. So I'm going to get this with an h factor out, n choose 1, which is n, x to the n minus 1, plus this with an h factor out, n choose 2, x to the n minus 2 times h, all the way down to n choose n minus 1, x h to the n minus 2, and that's 1 times h to the n. So when you pull out an h, you get h to the n minus 1. And all of this gets divided by h. Now since h is not 0, I can cancel it out. And then you get the limit as h goes to 0 of n choose 1, x to the n minus 1, plus other terms that all have h's in it. But h is going to 0. So you're taking the limit of that, and this term has an h, and this term, in the numerator, so they're all going to 0. So you just get the first one, n choose 1x to the n minus 1. And if you have n objects and you want to choose one of them, you can do that in any ways. You can pick the first one, or you can pick the second one, or you can pick the third one, up to and including picking the nth one. Now, there is your proof. There is your proof.